As a software engineer, your tech stack literally defines you. Many times, software engineers are not only labeled as back-end or front-end engineers, but by the specific technologies they use. So you'll often hear professionals say things like, I'm a Python developer, or a C++ developer, or even say things like, I work with the Mean stack, or I work with the MERN stack. All of this shows how integral your tech stack is to your developer identity. In this video, I'm highlighting 5 new technologies I'm learning in 2022 that I plan to add to my tech stack. I'm hoping that this video would help give you an idea of how I choose new technologies to learn that complements my current skill sets, and maybe you can apply this to your own use case as well. At the end of the video, I will reveal a similar list that I made last year, which I never got around to making a video about. And in fact, I did not succeed in learning everything on that list last year, and some of them are even on this year's list. So if you're interested in that, stick around until the end of the video. Number 5 on the list is GoLang. GoLang, or Go for short, is a programming language supported by Google. It is best for backend programming, and its syntax is similar to C. It also has some C features like garbage collection, and many tech companies are now adopting Go as their primary backend stack. The main reason why I am learning Go is not only because of its fast-growing adoption, but because I hear Go is super fast. Some resources have shown that when you compare GoLang to a reasonably fast language like Java, Go is faster in many categories. So I don't think I'm going to spend a lot of time learning Go coming from a C++ background, so I'm super excited about that. Number 4 is Unity 3D. I'm learning Unity for AR/VR development. So fun fact, I previously worked on extended reality and extended reality research for the NASA Suits program, and I co-authored journal-published articles about AR/VR, and my undergraduate thesis was about optimizing the power consumption of extended reality devices. So I'm pretty familiar with this technology. However, I primarily used Magic Leap for AR development, and when I worked with the Magic Leap, I developed the user interfaces in 3D space, but I mostly hard-coded the UI. But I could see how something like Unity could potentially help make that a lot simpler. I was hoping 2021 would be the year for mass adoption of immersive virtual technologies like AR and VR, looking at the current state of the world with the pandemic and the whole work-from-home situation, plus Facebook changing its name to Meta to reflect more on their commitment to the metaverse, and even vintage companies like Microsoft investing a whole bunch of cash into the metaverse. I believe immersive technologies would be a good improvement to enhancing virtual presence, but so far we haven't seen that much of mass adoption. If you look at Google Trends, the statistics for AR/VR interest, it has an intermittent up-down pattern, which seems to suggest that in some months AR/VR is popular, and in some other months it's not popular. And the cycle repeats all over again. And I think that's because AR/VR and other immersive technologies are in the early stage of development. And they require widely new set of hardware, which is expensive for many people to afford. Oculus has done a great job at making the Quest 2 reasonably affordable and bringing AR support to the Quest 2 also. But other headsets are ridiculously expensive. They're in the thousands of dollars. And the battery life is not so great either. You see, immersive technologies require significantly large update rates, and that significantly uses more power than other hardware devices, which means that excessive use of power impacts battery so much that you only get like 6 to 10 hours of like battery life running on full charge. So I'm hoping to not only get into the development part of AR and VR, but also the design part if I'm going to work on full stack projects. So yeah, that's why I'm learning Unity 3D and 3D modeling in general, and hopefully extended reality would be popular in the next couple of years, and it would be the next everyday computing platform, and we'll all get to spend our days with headsets strapped to our faces, banging into things, and living happily ever after in the metaverse. Number 3 on the list is TypeScript. TypeScript is JavaScript on steroids. I have been delaying learning TypeScript for a shamelessly long period of time now, almost in protest. And first, I really like JavaScript. It has worked for most of my needs. It's dynamically typed and the syntax doesn't have a lot of rules. And this means that if you're not careful, you're going to run into some silly type errors that could have been caught at compile time. And that's where TypeScript comes in. TypeScript is a strictly typed superset of JavaScript maintained by Microsoft, vintage company. It has optional static typing. For instance, you can explicitly declare variables that could only hold integers, which eliminates silly type errors. The keyword here is optional because that's why you can use TypeScript. You can use JavaScript code in TypeScript projects and TypeScript files. And that's exactly what I've been doing. I've been using regular JavaScript in TypeScript projects. Yeah, I'm a degenerate. Anyway, I'm finally learning TypeScript because coming from the React, Express, and Node.js background, many packages are being rewritten in TypeScript, so it's inevitable that TypeScript will soon be the norm. So I might as well just get over my JavaScript ego and not be left behind. Number 2 on the list is Rust. Now, it's funny because Rust made it to the #1 spot in my to learn list last year, but I wasn't able to do it. And now it's number 2, so if that doesn't get you excited about #1, I don't know what will. Right now, if you show me some Rust code, I would have no idea what it is. That's how novice I am to this language. But it's so popular. If we take a look at the Stack Overflow 2020 and 2021 developer survey, Rust is the most loved programming language by a significant margin, beating Python. And you know how passionate the Python community is. Recently, Elon Musk and Jack Dorsey tweeted in support of Rust, and I have also been talking to many software engineers, and it looks like Rust is just superior. They say it's syntactically similar to C++, and it achieves memory safety without the need for garbage collection. So that pretty much sealed the deal for me. Now on to #1, but first a quick word from our sponsors. No, I'm just kidding. I'm not monetizing the channel just yet, but it would be good for you to join our Discord and follow me on IG and Twitter for more behind-the-scenes content. Link in the description.
#1 on the list is Solidity. Solidity is a programming language used for writing smart contracts, and smart contracts are integral to the development of NFTs, DAOs, and Web 3.0 in general. While Web 1.0 was mainly focused on static web pages, and Web 2.0 was focused on user interaction and interoperability of websites, Web 3.0 is mainly focused on the decentralization of data. Now, regardless of what you think the future of the internet is going to be, whether it's Web 3.0 as it currently is or something else, one thing that's very clear is that at some point, the internet will transition away from Web 2.0. For now, the current state of Web 3.0 is the closest thing we have as to providing an insight into the future of the internet. And smart contracts are at the core of that. We are still in the earliest stages of Web 3.0, but that provides an opportunity to be a first mover in the space and get that advantage. Overall, I think it would be pretty cool to learn Solidity and build some decentralized apps, or dApps as they call them. So that's it for this video. I hope you got some value from it. If you like this type of content, you can support the channel by hitting the like button. Also subscribe for more content like this. Share this video around the community, and I'll see you in the next one. Bye!